Learn it fast, learn it smart, learn with us at Sofo. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from Sofo Learning. Today we will continue on the linear equations and review the algebra method in solving two linear equations. First, let us review the standard form of a linear equation with two variables. So we already saw that there are two variables x and y. Let's attach a coefficient a for x and b for y, and let's add a constant c and equate all that to 0. We will get a standard form, we will get a linear equation. Now the second point to remember is that the exponents of these variables x and y are 1. We are not dealing with x squared or y squared or x cubed or anything like that. This means that when we graph this equation, we plot this equation on a graph, we are going to get a straight line. So that's the recap for you. Now, we said there are two linear equations involved. So what we need to think about is a1x plus b1y plus c1 equal to 0, and the second equation being a2x plus b2y plus c2 equal to 0. We have the same variables x and y in the second equation, but we have the coefficients a, b, and c as different between these two equations. We have a1, b1, and c1 here, and a2, b2, and c2 over here in this second equation. Let me now create two examples for us to try and solve. So the first one is 2x minus y plus 3 equal to 0. Second one is 3x minus y minus 1 equal to 0. The key idea of the solution is to isolate a variable and then remove it using two equations. Now, as a first step, let's move this variable y to the other side of the equation. So we want to do that on both equations, but let's just focus on this one. How do we do that? So we have a negative y here. So in order to move it to the other side, what we do is add a positive y to this side, and because of that we want to do a positive y on the other side of the equation as well, so that we even it out. Now when we add the same value to both sides, the equation continues to be the same. Now plus y and minus y cancel out, so you are going to get 2x plus 3 on this side and y on this side. See? Now what we need to remember, the lesson here or the trick here is that when we are moving a variable from one side of the equation to the other, onto the other side of the equal to, we will have its sign change. So here it was negative y, when it moves to this side it became positive y. Now let's do the same thing here. We can do it in our head. We will do plus y on both sides, and we are going to get 3x minus 1 equal to y. Now let's notice the fact that we have y over here and y over here. They both are basically the same. So if y is equal to y, which we know is true, then this portion and this portion should be equal as well, which is our basic solution methodology. So 2x plus 3 is equal to 3x minus 1. Now remember what we talked about in moving things around. So we want to move this 2x to this side and this negative 1 to this side. This positive 2x will become negative 2x. So what will happen is that on this side of the equal to, it is 3x minus 2x, and this negative 1 will become positive 1 on this side, so it will become 3 plus 1. So this side is 3 minus 2, 1, x or x. In this side we have 4. So x is equal to 4. And that's basically the solution. Now let's just think about the value of y. There are two alternatives. Both of them should yield the same value. So let's first apply y equal to 2x plus 3. So 2 times 4 plus 3, that is 8 plus 3 or 11. Or the other option is 3 times 4 minus 1, and this is 12 minus 1 or 11. So there you have it. The value of x is 4 and the value of y is 11, and that solves both those equations. Let me show you an example where we have a fraction as one of the coefficients. I have two example equations here. The first one being half x minus y plus 3 equal to 0. So you have a fraction in the a coefficient corresponding to the x variable, and the other one is 3x minus y minus 1 equal to 0. Now our aim here is to remove this fraction first. To do that, you would want to multiply both sides by the denominator of the fraction. So you want to do 2 times here and 2 times here. If you multiply both sides of the equation with the same number, it doesn't change the equation. So we would do 2 times half of x minus 2 times y plus 2 times 3 equal to 0. 2 times 0 is 0. So this would cancel out. So we are going to ultimately get an equation that says x minus 2y plus 6 equal to 0. Alright. Now our goal here is to move this term to this side of the equation. Now we can do it in our head. We're going to get this equation x plus 6 equal to 2y. Now let's do the same thing over here. Move y to the other side. You're going to get y on one side of the equation and 3x minus 1, 3x minus 1 on the other side. Okay? Now you know that these two terms are not equal. One is 2y and this one is y. So we need to make them equal by multiplying 2 on this side and 2 on this side. So this equation would essentially become 2 times 3x, 2 times 3x minus 2 is equal to 2y, and this is obviously 6x minus 2 equal to 2y, and x plus 6 is equal to 2y. Now you can clearly see both sides are equal. 2y is equal to 2y. So let's just reduce this. 6x minus 2 is equal to x plus 6. So this x moves this side and this minus 2 move this side. So this would become negative x, right? And 6x minus 1x is 5x. And this negative 2 moves this side, becomes positive 2 plus 6 is 8. And so we get x is equal to 8 by 5. Now I encourage you to do this at home. Apply this value of x in any one of these equations and try to find the value of y. Thank you for watching.